In this video, we're going to be talking about multiplying polynomials, in particular a binomial by a binomial. So two terms being multiplied by two terms. Now, you've probably heard of FOIL before. And FOIL works as long as it's only two terms by two terms. You would multiply first, so the F stands for first, outer, inner, last. So the first terms in each parenthesis get multiplied, the most outer set of terms get multiplied, inner terms, and then the last two terms in each binomial. So that is one way, and if you've seen it, great. If you like it and can use it, great. The only problem I have with FOIL is that it only works for two terms by two terms. And sometimes it's not very pleasing to the eye. So if I am multiplying my first terms and then my outer terms, my inner terms, and my last terms, sometimes my arrows get lost. I multiply something twice, or I miss one of the multiplications. So essentially what's happening is we're distributing twice. We're taking this first term, multiplying it to both terms in the other parenthesis. Then I do the 3, and I multiply that by both terms in the other parenthesis. So we're just distributing that 2x to everything in the second, and then the 3 to everything in the second parenthesis. But again, if I use this distributing technique, sometimes my arrows get lost, or do something twice, or not enough. So the way I'm going to show you is called the box method. If I'm multiplying two terms by two terms, I would make a 2 by 2 box. I'd write one set of the term, or in the first parenthesis, I'd write them on one side of my box, so 2x and a positive 3. And then I write the other terms on a different side of the box, so x and a negative 8. And what I like about this method is it's a very visual method. So I just have to multiply each row by each column. So in this row, I would be multiplying by 2x. So 2x times x would give me 2x squared. Then I would do 2x times a negative 8. I'd get negative 16x. Then I go down to the next row. I do 3 times x. It's just 3x. And then I would do 3 times negative 8 and get negative 24. So what I mean by it's a visual method is I can see if there's an empty box, I missed something, right? So there's no question about whether or not I hit all the multiplication. Then I'm going to look at what I have here. So I have a positive 2x squared, a negative 16x, a positive 3x, and a negative 24. The order does not necessarily matter how you write it, other than our answers tend to be in descending order, meaning the highest degree down to the lowest degree. So what we could do here is start with the x squared, and then it really doesn't matter if you wrote the negative 16 or the 3x next. That doesn't matter. They're the same degree. And then the constant. And then what we do is we look for like terms. So I see I've got a negative 16x and a positive 3x. I can combine those like terms. Negative 16 plus 3 is negative 13. I still have my minus 24. And that's as far as we can go. We have no more like terms. So the trick is to take a 2 by 2 box, multiply each row and column together, and then combine like terms. Let's look at another one. So again, this is a binomial by a binomial, two terms being multiplied by two terms. I'm going to do a 2 by 2 box. And then write the terms on one side, so 4x and a negative 3y. And the other parenthesis set on another side, and then multiply them together. So 4x multiplied by 7x will be 28. X times x is x squared. Then I'm going to do 4x times a negative 2y, and I get negative 8 times x times y. Then I'm going to move down to the next row. I have a negative 3y times a positive 7x. Negative 3 times 7 is negative 21. And then alphabetically, I'm going to write x and then y. So you could write the y first and then the x because multiplication is commutative. However, I want it to look like this one and match. So in general, we're going to write them alphabetically. Constant first and then, or coefficient first and then alphabetically. In this last box here, I have negative 3y and a negative 2y. So two negatives make a positive 6. Y times y is y squared. Again, I'm going to look at what I have left. So 28x squared in the first box, negative 8xy in the next box, negative 21xy, and then a positive 6y squared. I combine my like terms here that I see. I have 28x squared, negative 8, and a negative 21 make negative 29xy. Remember, when we combine like terms, we add or subtract the coefficients, the variable stays the same. And then plus 6y squared. Nothing else is like. That's as far as I can go. Go ahead and try the 3 on the right. And be careful with this one. I've given you a hint here to think about what squaring something means. Alright, our next multiplication is 2 terms by 2 terms again. I'm going to make a 2 by 2 box. I have 2z plus 3 in one parenthesis and z minus 5 in the other parenthesis. 2z times z is 2z squared. 2z times a negative 5 is negative 10z. 3 times z is 3z. And 3 times a negative 5 is negative 15. I look at my like terms, and I've got 2z squared minus 10z plus 3z minus 15. There's my like terms, the z's, not the z squared. So I have 2z squared, and negative 10 plus 3 is negative 7z minus 15. Let's look at the next one. Alright, I have my 2 by 2 box with one parenthesis down one side, the other parenthesis terms on the other side. So x times x is x squared. X times a negative 5 is negative 5x. 5 times x is 5x. And 5 times a negative 5 is negative 25. If we look here, I have a positive 5x and a negative 5x. Well, 5 minus 5 is 0. So these middle terms add up to 0. So all I have left is x squared minus 25. And if we look at the original problem, these look like the exact same except for the plus and the minus in the middle. And that's actually how we get here, and that's going to always be true. These are called conjugates, meaning the exact same terms with the sign in the middle. One is positive and one is negative. When we multiply them out, that positive and negative of the same thing is what makes it add up to 0 for the middle term. I had a positive 5x and a negative 5x, and then the middle term adds to 0 and drops out. So whenever we multiply conjugates, we will get what we call a difference of squares. And we'll learn more about that when we talk about factoring. Alright, this last example here says n minus 6, that whole quantity squared. Now I'm going to do two things. This is the most common thing that I see students do. They try to do this. And they say, oh, the answer is going to be n times n is n squared, and negative 6 times negative 6 is positive 36. Okay, well, let's keep that there for a minute, but then let's think about what a square means. So if I want to square this whole quantity, this whole parenthesis, squaring means multiply it by itself. Whoops, didn't mean to zoom that in. So when we do this, n minus 6 squared really means n minus 6 times n minus 6. So again, multiplying or squaring means multiplying by itself. Alright, so write it out and then let's do the box method and see what happens here. So I'm going to draw a 2 by 2 box and then fill in n minus 6 and n minus 6. Multiply it out. So n times n is n squared. N times a negative 6 is negative 6n. Same thing here, negative 6n. And a negative 6 times a negative 6 is 36. Notice that these two middle terms are not going to drop out. This is not 0. Negative 6 plus negative 6 is not 0. I'm going to write it out here. But I have n squared minus 6n plus 36. Negative 6 plus a negative 6 is negative 12n plus 36. This is the correct answer, and this is not. Notice that we do not have this middle term of negative 12n. It's gone. It's not there. So you cannot distribute across sums and differences. You can use an exponent across if it's only multiplication, because an exponent is multiplication. It's a shorthand for multiplication. So you can distribute exponents across multiplication. You cannot distribute exponents across sums and differences. All right, let's look at two more that are a little bit bigger. So here, this is two terms being multiplied by 1, 2, 3 terms. Now I'm going to need a 2 by 3 box. So make one side a little bit longer. And of course distributing works as well. As long as the first term gets distributed to every term in the second parenthesis, and the second term gets distributed to everything in that second parenthesis. That will still work if you prefer that. I will never force you to multiply this way. So I'm going to write the two terms on one side, so p and a positive 2. The three terms on the other side, p squared, positive 3p, and a positive 1. And then multiply each box. P times p squared is p cubed. P times 3p is 3p squared. P times 1 is p. 2 times p squared is 2p squared. 2 times 3p is 6p. And 2 times 1 is 2. Then we look for the like terms. So I can see here I have p squareds. I have the p, the two just regular p or p to the first power. So if it helps you, you could write it out to visualize all of these next to each other. I'm going to do it in descending order, so 3p squared, and then the 2p squared next, and then the p to the first degree, the other p to the first degree, and then the constant. I can see I have like terms with my squares, I have like terms with the first power, or first degree, and I have overall p cubed. 3p squared plus 2p squared is 5p squared. Remember, the variable stays the same. And p plus 6p, so 1p plus 6p is 7p, and plus my constant. And that's as far as we can go with that. Go ahead and try the one on the right. Okay, so we have our 2 terms being multiplied by 3 terms. I made a 2 by 3 box. I have 2 terms on this left-hand side and the 3 terms across the top. I multiply my boxes. So 3y times 2y squared. 3 times 2 is 6. Y times y squared is y cubed. 3y times negative y is negative 3y squared because of that y times y. 3y times 5 is 15y. Negative 2 times 2y squared is negative 4y squared. Negative 2 times a negative y is a positive 2y. And negative 2 times 5 is negative 10. I see some like terms with my y squareds and then my y. I'm going to go ahead and combine those. I had only one y cubed, so I bring that down. Then I have negative 4y squared and a negative 3y squared would be negative 7y squared. 2y plus 15y is 17y. And I have my negative 10. No more like terms. That's as far as I can go. Notice how I just added these as I wrote it, or you could expand it out here and then combine your like terms.